Hello, all you wonderful people. Welcome to lesson 15, problem set and concept development video. We're doing both of them today in the same video because it is all word problems today. So remember to have your reference sheet out. I've also posted it under today's lesson. It's under Thursday's lesson, under Tuesday's lesson as well. And then we also put it in our computer bags if you are an Alpha or Omega student. So that's going to be helpful for us to be successful with today's lesson. So let's go right into our word problems. Now we're going to have to be thinking of whether or not we're going from larger to smaller units, which means we're multiplying, or if we're going from smaller units to larger units. So let me just, let's think about that real quick. That's going to be our number one challenge today because we've practiced all these skills. Now we're just trying to say, are we going from larger to smaller or smaller to larger? So if our unit goes this direction, 1 into 100, so if we were going meters to centimeters, that's a multiplying situation, right? Oops, multiply. But if they're asking us to go from centimeters to meters, well, we're going smaller. I mean, our number's getting smaller, which indicates that we're using larger units. So this is where we're going to be dividing, using our knowledge of dividing. So we're going to use this week's lessons of converting our units on our word problem. So we're looking to see if our units are getting smaller where we multiply, or if our units are getting larger and we divide. So without further ado, let's get into it. Let me zoom in. Fit to width. All right. My name on it. I can already tell that my pen tool is a little too fat, so let me change that. All right. So it just says solve. So we're going to follow the read, draw, write method. We're going to read it. We're going to draw. So we could either draw any models we need, tape diagrams. We could just use standard algorithm. That's considered in the draw category. And then write. We're going to write a statement to answer the question. So read, draw, write. So let's start with the read. Liza's cat had 6 kittens. And when Liza and her brother weighed all the kittens together, they weighed 4 pounds, 2 ounces. Since all the kittens are about the same size, about how many ounces does each kitten weigh? So first thing we need to do is go back to our reference sheet, pounds to ounces. So I see pounds to ounces there. I'm going from 1 pound for every 16 ounces. So our units, when I see the numbers getting larger on the other side, I know the units are getting smaller because we're cutting it up into smaller pieces. So, whoops, wrong page. So we know that 1 pound, I'm just going to write this note over here, equals 16 ounces. So I'm going to write a little multiplication sentence first. Well, first I'm going to do 4 times 16. And then I'm going to add back those other 2 ounces to find out how many ounces altogether. Once I do that, it says since all the kittens are about the same size, about how many ounces does each kitten weigh? Well, then we need to divide that by 4. I apologize, we're not dividing by 4, we're going to be dividing by 6, right? Because of the 6 kittens. So let's go ahead and get started with this. We're going to go ahead and work inside the parentheses first. So we're going to do 16 times 4. I'm going to go ahead and pause, and you're going to go ahead and solve that part. All right, as you can see, we have the 64 ounces. So if I put it back into my number sentence, I have 64 plus 2, and then I need to divide that by 6. So 66 divided by 6. Now, we should be able to do that in our head because that is a basic multiplication factor or division factor, I should say. So I always think of it backwards. So I think about what times the divisor is going to give us our dividend. So here's our divisor. Here's the dividend. What times 6 will give us 66? Now it's double the digits. So we know that that must be a multiplying or dividing by 6 times 11. See, I can't talk this morning. All right, so we know each kitten should be weighing around 11 ounces. OZ is the way to abbreviate ounces. And now we just need, so we've read it. We drew all of our numbers and our math expressions to help us think. And now we're going to go ahead and write our statement. Each kitten weighs about 11 ounces. All right, let's go ahead and move on down here. And actually, let me just zoom up here in case people want to check their work. All right. Now let's go ahead and read this question. All right, a container of oregano is 17 pounds heavier than the container of peppercorns. Their total weight is 253 pounds. The peppercorns will be sold in 1 ounce bags. How many bags of peppercorns can be made? Oh, this is a tough thinking word problem. So let's just, sometimes when I read a word problem like this and I'm like, whoa, I think it's time to draw a picture to help me understand it. So these are the ones where I really like tape diagrams. So I know oregano is 17 pounds heavier than peppercorns. So I'm just going to draw one that shows a tape diagram that shows 17 pounds heavier. But we know altogether, well, that was a bad like altogether symbol. Let me try that again. Let me just do this. All right. So I need to also label these. Oregano on top. And we got peppercorn on the bottom. So we know that this is 17 pounds heavier on the top. We know the whole thing weighs 253 pounds, all of them together. So how can we figure out how many peppercorns can be made? Well, we need to figure out how many pounds peppercorn is. Well, we know this one, oops, I didn't mean to scroll up. Come on, toolbar, I need my tools. All right, we know that this section and this section of the oregano and peppercorns are exactly equal because they told us that the only difference is this 17 pounds right here. So our first step is going to be to take our 253 and we're going to subtract those 17. And then what we're going to do is, because we know that they're equal, we're going to divide it by 2 to get just the peppercorns. But then we have to convert that into ounces because it's saying they're sold in 1 ounce bags. So we will worry about that next. Let's go ahead and solve for this. 253 minus 17. This is a tough word problem. You really need to be a critical thinker with this one. So I see that it's 236, and then we're going to divide that by 2. Ooh, can't do that one in my head. So let me just go ahead and do my long division here. I know one group of 2 will come out of 3. And then that's 6. Okay, so I know it's going to be 8 groups, no remainders. So our quotient should equal 118 pounds. So we know the peppercorn is 118 pounds. Just for a quick understanding check-in, how much would the oregano be? Well, yeah, you got to add back that 17 to the 118 to find out what oregano is. But we don't have to worry about that. We're worrying about how many bags of peppercorn can be made. But we're looking at 1 ounce bags. So again, If you can't remember from question 1, let's go ahead and look at it. 1 pound equals 16 ounces. So once again, we're going pounds to smaller units. So we're going to be multiplying. So we need to take our 118, and it said 1 pound equals 16 ounces. So we need to take 118 times 16. I'm going to pause. You're going to pause. You're going to go ahead and finish that math problem. Check your work here in a second. All right, now that we've done that math work, we can check it. It should be 1,888. I apologize that my 8s are a little sloppy, but we knew that we turned those into ounces. So that's why the answer is in ounces. But now we need to write the statement for the question. It said how many bags of peppercorns can be made. We know that they're in 1 ounce bags, so it should be exactly the same number as how many ounces we have. So how should we word it? There will be, we can just say 1,888 bags of peppercorn can be made. All right, nice job. All right, on the back, let me just zoom up so that people can check their work if they need to. Now on the back, we're going to be working the opposite direction. We're going to make our units larger. So now we're going to be thinking of division. So let's go ahead and read the question and then let's get into it. Each costume needs 46 centimeters of red ribbon and 3 times as much yellow ribbon. What is the total length of ribbon needed for 64 costumes? Okay. So once again, this is one of those ones where my brain goes, what? And so when that happens, I like to draw pictures. So I know that the red is 46. And then they're saying yellow is 3 times as much. So I'll just do 3 little boxes that I know each one of these is 46 because it's 3 times as much. What is the total length of ribbon needed for 64 costumes? So first I need to figure out what this equals, and then take that question mark and multiply it by 64 costumes. But it wants it in meters. So then we're going to have to convert. So those were centimeters over there. Okay. Lots of steps here. Let's go ahead and try it. Well, 46, and then let's first start figuring out how many centimeters for every costume we need. We have 4 46s, so let's go ahead and multiply 46 times 4 real quick. So that's 20, whoops, wrong spot for the 2. 24, 4 times 4 is 16, 18. So we know we need 184. Make sure your unit's following so you don't get lost in this. This is 184 centimeters. So now that we know that how many centimeters we need for each costume, so we now know it's 184 times 64 is our math problem. So let's go ahead and solve for that. I'm going to change colors so it doesn't get lost in all the other work. 184 times 64. Go ahead and pause, solve, and join me to check your answer. All right, so now I've completed the work. Remember, if we're analyzing our work, when you're checking it, made a mistake here on your partial products, it's a multiplication mistake, make it down here, and it's an addition mistake. But now, remember, this is why I said make sure your unit's following you around. We need to remember that these were centimeters. Now, you'd think we'd be done already, but this is 5th grade math, so there's lots of steps. We got to make sure we read the question and make sure we've done it. So each costume needs 46 centimeters of red ribbon and 3 times as much yellow ribbon. We got the ribbon. What is the total length of ribbon needed for all 64 costumes? We know how many centimeters it is, but then it says right here, express your answer in meters. Okay, so centimeters to meters. Let's go, whoops, I didn't mean to draw on this board. Centimeters to meters, let's go to our reference sheet, centimeters to meters. And sometimes you have to look at it the other way, meter, but we're going this direction with this, centimeters to meters. So we know that we're going from 100 to 1, so we're dividing. Our units are getting larger. So let's go ahead and take a look at that. So we know that it was 11,776 centimeters, and we're multiplying that by 1/100 meters. So really what we're doing is we're dividing 11,776 divided by 100. Now, when we're doing that, we have to remember where our decimal place it would be. It would be after the ones place. So now we're shifting it. We're dividing, so our numbers are getting smaller. So we think about 2 shifts. So our answer should be 117 and 76 hundredths, but this is of meters. Good. Now we need to express our answer with a statement. So we've read it a couple times. We've drawn all of the work we need to draw, and now we are going to answer it in a statement. So 117.76 meters of ribbon is needed. Good. All right. Let's go ahead and check out this bottom question and see how we do on this one. Whew, lots of work. Nice job. Keep it up. Almost done. When making a batch of orange juice for a basketball team, Jackie used 5 times as much water as concentrate. There were 32 more cups of water than concentrate. So again, if we think about a drawing, this one should have 1, 2, 3, 4, 5 times as much. So this was water, and this was our concentrate. But there were 32 more cups of water. So we know that this was 32 cups. Okay. Let's just think about this for a second. So at some level, it doesn't feel like they've given us enough information, right? But let's try to use what we know. Well, there's 1, 2, 3, 4, 5, 6 different units altogether. So I'm just going to represent that. I'm just calling them units because they didn't really, we don't know how much are inside them. So I'm just going to call them 6. But we do know that 32 cups spreads over 1, 2, 3, 4. 32 cups for 4 units. So if we divided those 32 cups into those 4 groups equally, we'll think backwards multiplication. What times 4 gives us 32? Oh yeah, the answer would be 8 cups. So we know that each unit should be 8. But what else do we know? Well, there wasn't just 8 or 4 units, there was 6 of them. So altogether, whoa, I didn't mean to work. Oh, I undid it. There it is. 6 times, yeah, now we have to bring it back for all of our units. So we're doing 6 times 8. Well, 6 times 8 cups equals 48 cups. So let's just make sure we've got all the work. How much juice did she make it all? Well, 48 cups of juice were made. Sorry about being sloppy with my handwriting. So sometimes we have to figure out, we might not know all of the parts to the story, but with the little parts that we can do, we can extrapolate it, which means pull it out and then spread that information across the parts that we don't know. So we use these 4 parts to figure out all the other parts. Great. So now it's just saying she's poured that juice into quart containers. So we're going from cups to quarts. Oops, a bad Q. Come on, Q. There it is. It's bad anyways. But anyways, let's go to the reference sheet. Cups to quarts. Cups to quarts. I see cups. 2 cups per pint. But then there's 2 pints per quart. So if we just multiply 2 cups by 2 pints, we'll have our answer. There's going to be 4 cups for every quart. Okay, that took a little bit of thinking because we had to go from cups to pints to quarts. Well, there's 2 pints, well, 2 plus 2 for cups. So it's 4 cups. All right, so let's go, whoops, wrong page. So we know each quart is 4 cups. So 4 to 1. So if we're thinking about this, we have 48 cups, and we said the relationship of quarts to cup, or cups to quarts, was 1/4. So now we know that it's 48/4, because we now know how to, we've been practicing that. So we know that we're going to have to divide 48 by 4 to figure out how many quarts there were. Well, 10 times 4 is 40. And then 44 would be 11 groups of 4. 48 would be 12 groups. Oops, come on, what happened? Where'd my pen tool go? Somehow I'd shifted to the texting tool. Still, come on. 12, but what? We went to quarts, so 12 quarts. And so how many containers she could fill? She can fill 12 quarts. For a little extension, how many gallons could she fill? With 12 quarts, there's 4 quarts to a gallon. So how many gallons would that be? Yeah, it would be 3 gallons. All right, nice job. That was just a little extension, that 3-gallon part, but now we are going to our exit ticket. So do your best on your exit ticket, following the read, draw, write method. I want to see your thinking. I want to see how you got to the answer. All right, nice job on today's lesson, and have a great weekend, guys.